So for what we're going to be doing in this course, I cannot stress enough how imperative a strong foundation in algebra is to success in this course. So this is not going to be teaching the algebra. I've got a bunch of videos linked in the description for all the things that I'm going to sort of state right now, but I just want to tell you what you should be really comfortable with. And that is, you should be comfortable with graphing in general, right? Graphing. Understanding the graphing plane, understanding how, just plotting points, connecting them, understanding how graphs look, especially like polynomial graphs, that will be important. You should know properties of exponents and logarithms. You should know about the number e, which is, remember, approximately 2.71828, right? You should understand all of these. Definitely some basic geometry, but that will be, the trigonometry. I'm going to cover that in a video, just a brief overview. Now, when I say properties of exponents and logs, it's going to be stuff like this. X to the a plus b is equal to x to the a, x to the b, right? Stuff like that. Or, the log, natural log of, and if you don't know what the natural log is, that goes along with the number e, so you should know what that is. Natural log of ab is equal to ln of a plus ln of b. And there's a lot more stuff to this, but it's stuff like that. Things where you can expand and combine logarithms, expand and combine exponents, like x to the a, all of that to the b power, then you multiply the exponents. It's stuff like that. Just understanding these properties and being able to work with it. I'll have videos in the description on that. You should know how to factor quadratics. You can use the quadratic formula to factor quadratics. You should know the quadratic formula. You should also know, for quadratic equation, x is equal to negative b, quadratic formula, plus or minus the square root, b squared minus 4ac, all over 2a, right? We're actually, in quantum mechanics, going to be using the quadratic formula, so it's not just this weird thing that you'll never use. The other thing, and I'm going to touch on this just for a minute. Hopefully you've got this down. If you don't know it, make sure you look at it. One thing I'm going to touch on, I'll have a video on it, are even and odd functions. Right? Even and odd functions. And what I mean by that is an even function, f even, of negative x, right, is equal to f of x. Oh, also, you should understand function notation, right? And this is f, right? This f even. The even is just sort of a subscript. It's just denoting that f is even. But you should understand what f of x means, how, you plug in things to f of x. And, if I say f of x equals x squared plus 1, you should know that, f of, for example, f of t squared, it would be t to the 4th plus 1. Also, solving basic algebraic equations involving exponentials and logs. I figured that went without saying, but I'll say it. Also, f odd, right? F odd is equal to, so f odd of negative x is negative f odd of x, right? So an even function, you plug in negative x, and you get the same thing, right? And that's sort of like a flip, right? I don't know, whatever it looks like. A flip across the y-axis does nothing, right? It doesn't change the function. For an odd function, a flip across the y-axis changes the function by just, I didn't draw it perfectly, but if you flip across the y-axis, it becomes negative itself, right? That's an odd function. I can also show that if I have f of x, right? So if I have some f of x, right, I can show, right, that this is equal to sum f even, the sum of some f even of x plus f odd, or f odd of x. And all this is any function is a sum of one even function, one odd function. I can always find an even function and an odd function Now, if f of x is even, then there is no odd part, and if f of x is odd, there is no even part, right? But for any general f of x, right, there is an even part, there is an odd part unless f of x is even or odd. But any not like function that's not necessarily, because these are special properties, not every function will follow these properties. So any general function can be written like this, such that f even of x is equal to f of x plus f of negative x, and f odd of x is equal to f of x minus f of negative x. And you can actually show easily, one, that these two add up to f of x. That's really easy. And also plug in negative x here, then plug in negative x here, and then this would be negative x, and show that f even of x and f odd of x are indeed even and odd. And then you can prove just from that you can add up this even function and this odd part, right? This is the even part of x, it's the odd part of x, can add them up to get f of x. This is just an important concept in algebra. You may not have learned this in your algebra class, but it is extremely important in quantum mechanics, and we'll come back to it. And I'll have a video on even and odd functions, like a linked video from someone else. So, again, that's really it. It's not, you really just should know basic algebra for this course, and I just wanted to give a really brief overview. Okay, that's it.